everyone. Thank you for choosing us versus the Sex and Love session. That also starts at 11:30 in case you have any doubts. My name is Meur, and I am thrilled to have such a wonderful panel and conversation today about AI. So let me introduce the speakers, start there, and we should get right into the topic. We've been preparing a little, and the one thing that stuck to my mind was, are we going to be or remain the most intelligent species on this planet in the years to come? And I think that's kind of a main topic we're going to discuss and try to answer. And to do so, we have Daphne Koller, who is a professor at Stanford, who is a Genius Grant of a MacArthur Award. So we have a genius here. And she's also a TED speaker and very secretive about Daphne's next mission and job, but I'm sure it's going to be exciting. Then we have Adam Chayer. Adam co-created Siri 25 years ago.
Version 1.
Version 1 of Siri 25 years ago. There is no need to explain what Siri is. Now he's also co-founded Viv Labs that was acquired by Samsung. And he's about to, can I say that, release?
Coming soon.
Yeah, coming soon. This year? Okay.
Supposedly.
Okay, all right. Well, no news here, but there is a Siri of Samsung coming soon. And then we have Nell Watson. Welcome, Nell. Who was reading 2 books on philosophy, and Nell has a passion on machine ethics and tech philosophy, and the future of society. So this is going to add a very interesting dimension that we should talk about. And of course, I could go on and on your bio, but you are also a Singularity University professor, and you are an engineer and entrepreneur. And I'm also an entrepreneur, and I started a small startup that is a platform for speaking called Leaders, because I love being able to have amazing experts here. So thank you all for making it. So why don't we start with what just happened and what is now currently here. Adam, why don't you start by, you were telling me what's really, really amazing for you is that you've been always surprised yourself as you've built Siri by what happened that you didn't expect would happen in AI.
Right. So it's really rare, I think, in most fields that you can make a statement like I'm about to make. So I've been working in AI for now more than 30 years, and I can say that in the past 8 years, there are things that have occurred that I never thought would happen in my lifetime. So you're working, you kind of get a sense of how the field is progressing, and literally in the last 8-10 years, there's been a hockey stick where I couldn't believe what I was seeing. And I'll give a few examples, and maybe others can jump in and see if maybe I'm just too excited about this. But one thing that happened for me, the original Watson Jeopardy playing program went beyond my expectations. So I know there's a lot of hype perhaps around Watson, et cetera, but the first one, when it could answer in natural language questions from a really wide, broad knowledge base, and synthesize answers. The thing that really scared me was when I saw one of the answer was Batman and Robin Hood. And I'm like, that is not information retrieval. And there was some kind of cultural, obtuse question that emerged with that answer, and that a machine could know enough about everything going on in our life to synthesize that answer. I was like, wow, that's pretty cool. A second one that some of the robotics work, I don't know if you've seen some of the machines recently from Boston Dynamics, like the humanoid.
We've all seen those videos of the scary robots.
Who can do the backflip and
open doors.
The first one that I saw was when the Sony Aibo first came out. I saw a prototype. It was a little dog just wire, there was no casing, just wires and lights, and it was playing robot soccer, and it scored a goal, and then I'm telling you, it did this little dance kind of thing, and I never thought that I would feel such emotion for this physical batch of wires and circuits, and yet there was something about the physicality that blew my mind, and I said all of my dreams and maybe fears will come true if really robots and machines can move like that. It was beyond my expectations. So I don't know, I have many more, but I thought I'd let others. But the big part, last 8-10 years, there are things that experts did not think would happen in their lifetime. That's a big statement.
Oh, yeah.
It is, and before I forget, I was told to remind you that you can ask questions using Slido, and we have them showing up on the screen, so whenever you want, I'll make sure to throw as many questions as we can. Daphne?
So my two favorites, I mean, I love the ones that Adam mentioned, but my two favorites, the first is actually machine translation, where we're getting close to human level performance, or maybe very close in some language pairs. And to me, that one's inspiring not only because of the achievement in terms of what AI and machine learning has been able to do, but also because of the societal implications of being able to communicate with someone whose language you don't understand in what will soon be sort of an almost seamless interface. And I think that from the perspective of just bringing people together across cultural divides is just such a hugely significant aspect. So to me, that one has been a hugely dramatic and important achievement. Another one that is, I think, just very cool is the ability to take images and say what is in them. And that one currently is not quite at the stage of maturity in terms of practical application, but in terms of performance, they've actually surpassed human performance in a lot of cases. And if you think about the applications that are not too far off on the horizon, which is helping the blind to see, I think that also is one that I'm particularly excited about.
I love that application, and just want to emphasize, it's not just recognizing the 10,000 things in an image, it's synthesizing the meaning. Exactly. What is the best phrase that captures the essence of an image? Exactly. And so the first is amazing. The second one blows my mind because the complexity of knowing what to ignore and what to highlight and how to phrase it, the level of performance when I see that work, it's like, boom.
Yeah, I mean, this synthesizes statements like 3 dogs playing frisbee on a beach, and that really captures what's going on in the image, and it doesn't tell you how many clouds are in the sky and that there is a pail left that a child left there. It really focuses and tells you what you're supposed to be seeing in that image. And again, I think the implications of that from the perspective of helping people are potentially immense.
Daphne, what form will it take, the translation part? So I speak into what? My phone? My phone speaks in Portuguese.
That is where we're at that point right now. This has just literally been announced.
Real time?
Real time. It's not quite, that's not quite, I think, fully ready and baked yet, but the stuff where you read an email and it's in a different language and you click translate and it tells you what's in that email, and then you write an email in your language and it sends it back to the other person, that's done. That works. Right. The real-time speech version, I think we're a couple years away from that being fully productized, but a prototype has just launched.
Why is that AI? Why is that intelligent?
You really, because it's not a word-to-word translation. You're not looking at a dictionary and saying the meaning of this word in this language, or the
context.
The context, idioms, really, I mean, there's just so much ambiguity in natural language that people have tried all those sort of rule-based systems for many, many years, decades, in fact, and what comes out is gibberish, and no one understands it. And now you actually read what the system has produced, and it sounds like a human translated. It's a human translator level. And I think that's much, much harder than people realize. In fact, I think that's what characterizes a lot of the work that AI and machine learning have been able to do in the last few years, is that it's solving the problems that are easy for people and were really, really hard for machines. And that was a revelation, I think, in the early days of AI, where people thought, oh, chess is going to be the hardest thing. Chess isn't actually the hardest thing for machines. It's actually hard for people, but it's not that hard for machines. Whereas what's easy for people and really hard for machines are all these like pattern recognition things that are like, well, that's a dog. Well, of course that's a dog. That's really hard for machines to figure out.
And that's done now. Nell?
I'm fascinated by the synthesis of content, things like generative adversarial networks. It's really the closest thing to Harry Potter. You know, you can take a sentence and breathe that sentence into reality, like a description of a bird or a dog, or creating entire human faces that look believable of people that don't exist. And I'm fascinated by where that's going to take us in the years to come, when anything can be generated at will, kind of like the holodeck in Star Trek, just by a description, and what our society might look like when anything can be counterfeited at will.
Can we take a break and go back to human intelligence? Because we're talking about artificial intelligence, but what is intelligence? Just to be, not even artificial, what is it? What is human intelligence? Do we understand it? Do we understand the brain really before we talk about artificial, or do we need to?
It's clear that we don't understand the brain. We don't understand the brain at the level of individual neurons even, and we certainly don't understand how those individual neurons come together to form what we perceive as intelligence. My statement would be that while that's a really, really important scientific question, it is neither necessary nor sufficient for the purpose of building artificial intelligence.
So wait, let me understand. We don't need to understand human intelligence to create and understand machine intelligence.
We don't know. I mean, there's no reason to believe that the fastest path to machine intelligence is by replicating the path that evolution led us in terms of creating natural intelligence. I mean, the obvious analogy is flight. Airplanes work nothing like birds. All of the attempts to replicate flight that is bird-like have failed. And I'm not sure that replicating human intelligence is the right way to build machine intelligence. So should we understand human intelligence? Absolutely. Is that the best way to engineer an intelligence? Not so clear.
But
Adam, you were talking about
one example. I love that, that question. Google and DeepMind came out with a program called AlphaGo, which beat the world's best, or one of the world's best Go champions. And it was trained on all of the best human games. So here are the grandmasters of Go. Here's how they approach the game. And it was great, and it beat one of the world's best humans. But then they created a version called AlphaGo Zero that did not train on human games, and it learned just by playing itself. So it started basically with no knowledge, and it played
zero knowledge.
AlphaGo Zero started with zero knowledge. Mm-hmm. You ran 2 copies of the program, and you saw which one won. And then it learned, and they played trillions and trillions of games. And whereas AlphaGo, the first version, I think it won 3 games to 1 or 4 games to 1 against the human, very impressive. AlphaGo Zero beat the original AlphaGo, which is already one of the best or the best player in the world, 100 games to 0. And what was fascinating was it was no longer constrained to human knowledge, right? It derived and learned its rules without looking at what humans over centuries have learned as best practices. It could go beyond that and derive new things. So to your point, understanding how humans do it is not necessarily the best way to achieve intelligence or superintelligence. And if you let machines be unconstrained, maybe they'll find better ways than we do it, because they can use new tools, new techniques. And that for me, was a pretty stunning achievement.
Can you define intelligence?
No.
I would say that intelligence is the ability to analyze different potential options and choose one that is most favorable. That would be one definition that I would use for intelligence. And I think that there is a lot that we can still learn from neuroscience. I think neuroscience can still inform machine intelligence in many different ways. And I think there is a virtuous cycle, because the better machine intelligence we have, the greater refinement in our ability to understand the human mind and to model it, and that comes back into our models of how to engineer this stuff. I think that's one of the reasons why we've seen so many advances in neuroscience in the past few years.
I think that's a great definition and probably the right definition. I want to augment or alter it a little bit. To me, intelligence are lots of little things. It's humor. It's the emotional intelligence. It's not, you know, when you say just making the optimal decision for a path, to me you get the chess computer. And even though we've created a computer that can beat the world's best human in chess and is obviously a master at that game, I don't really consider Deep Blue intelligent like a human is intelligent. Humans have intuition, they have emotions, they have judgment, and it's not that machines can't attain that, because I think they can eventually. I think we're not making much progress on those aspects. We're very good at making those decisions and those applied decisions. But I think if we limit ourselves to a definition where it's purely about achieving the task, that's not capturing intelligence. There's something more that makes, what I consider human intelligence today is beyond, in certain capacity, what I see maybe more machine intelligence is, which is more about making those decisions.
Is there something unique that Daphne?
Counterpoint.
Well, I want to argue about that a little bit. One of the definitions that I used to give my Stanford students when I taught the AI class, which I read in a book, is that artificial intelligence is the task of building, of solving problems that are easy for humans but machines cannot yet solve. Now, if you think about that definition for more than 30 seconds, it basically means that every problem that you solve is no longer artificial intelligence once you solve it. Because once you solve it, it's no longer hard for machines to solve. So I think over time, we've removed more and more stuff that used to be considered artificial intelligence from the definition of what constitutes artificial intelligence. And I wonder if in 5 years, it's like, well, of course machine vision isn't artificial intelligence because we've solved it, and so it's not intelligent. And so I think we should be careful about not diminishing from the contributions of the field as we've tackled more and more problems that used to be considered really, really hard.
Oh, absolutely.
And these are achievements, I think, of that field.
But so I'll take the second one here. Is there a seminal moment where robotics, interpretation, and language come together? So language plus robotics. And I want to add, we're all, please don't take this in the wrong way, but we're all using or tried Siri. We're all using Alexa that had a lot of conversations in the last days, doing weird things. We are, honestly, each time I do, I'm disappointed so far. I have an Alexa box in my kitchen, and I say, I have eggplant, and I have this in my fridge. What can I do with it? That doesn't work very well. But I can ask something very precise. So it's pretty disappointing. So we're talking about breakthroughs with language, with translation, but really the reality is, Siri barely understands me when I speak with my accent right now.
So I'd love to.
Sorry.
I barely understand you with your. No, just kidding.
Can we get some translation? Maybe I should need an app too.
Yeah, one funny story. I won't name names, but at Apple, one of the top engineering managers was French. Oh. And he was using Siri, the early prototype. And he goes, it doesn't work for me. I said, play Bob Dylan, play Bob Dylan. And it doesn't understand me. And everyone, come on, Michel Jackson. And it was, and we're like, okay, play Michael Jackson and Bob Dylan.
Oh, I know, tell me about it. So is that fixed now?
So let me say a few. It's better. So 2 things. On the accent side, at the time when Siri and others came out, speech recognition really comes from the data. And at the time, the only transcribed audio data that existed was from things like broadcast news announcers and political things where it's recorded and transcribed by law. So as long as you sounded exactly like a broadcast news announcer, which has a quote, you know, neutral accent or whatever broadcast news, or it's whatever that, it's not, you know, as long as you sound like that, it worked very well. But if you were a child, female, had a regional accent, you varied from the data set. But the good part is over the last years, who has been talking to Siri and others, it's everybody, right? And so as the data comes in and it's pouring in, and as it gets transcribed, speech recognition is improving for these areas. So I think speech will get better for everybody, not just for the broadcast news announcers among us. One point I asked about, it's not just about speech recognition. You said, I have eggplant in this and I want to do something interesting. Most people don't realize, but I believe we are on the brink of a new paradigm emerging. Just like, imagine we were 1 or 2 years at the start of the web, right? And this is where assistants are. So every 10 years, the way people interact with computers changes. Mid-'80s, the PC landed on your desk, and everyone had to learn how to use the mouse and Windows and things like that. 10 years later, it was a web browser, and now it was about hyperlinks and URLs and back buttons and bookmarks. 10 years later, approximately, the smartphone, and we are now 10 years into the smartphone. And this year is the 10th anniversary of the App Store. So for me, the real problem with assistants is that to date, they've been built by one company. It was an Apple or a Google or a Microsoft who coded up everything. And they have lots of people and great engineers, but you cannot have one small company entering in intelligence. And so we believe, and not just us, but the field is now moving towards an ecosystem approach, where like the web, like mobile, where you have apps, it's the world who's going to teach the assistants. And at that scale, that's where we will go from here, where an assistant is a utility. I can send a message, play a song, get the weather, but I can't do everything I can do on the web or everything I can do with an app. But that's about to change. And companies like Amazon with Alexa, they have 25,000 skills. I still can't use them. The paradigm, even though it sounds great, I have to say, Alexa, ask App 7 to do Command 5. No, literally. And with that, I can't keep track of 25,000, or if there were 1 million apps out there. It would be like having the web with bookmarks only and no search engine, right? You can't discover them, you can't use them. So companies are pouring billions of dollars into how to create a scalable ecosystem, but this will be solved in the next 1 to 2 years.
Yeah. Shouldn't it be solved now with, so the style you were talking about with AlphaGo, that machines will just learn by themselves?
There are, and this will be a great thing for the panelists to discuss. Today in AI, there are things that AI can learn, and there are things that are beyond the capability really to learn. We're very good at learning from label data. Given this input, machine, like if this is in English and this is Swahili, here's the equivalent, this is the answer. And you do that for lots and lots of examples, machines can learn that and do amazing things. But how do you learn all of the services in the world? You know, all the web pages, all the content that you can't. It's not training, doesn't fit machine learning model. So we need the world's developers to teach us. And I believe that it's starting to emerge, and within 2 years, 2 to 3 years, you will use an assistant for everything that you use the web for and apps, and it will be better than either of them. And it's not because of voice. Many people think Siri, oh, it's speech recognition. If I said, help me plan a trip to my sister's wedding next month, I could be sitting at the keyboard of my desktop computer with my web browser and my phone right next to me. I still have to repeat over and over again you know, it's going to be in Dallas, and it's on this date, and I'm bringing 3 people, and I have to figure out how to get there, where to stay, what to eat, what gift to wear, what clothes to wear, what gift to bring, etc. I want an assistant who knows my preferences and can help me do all of that. And that kind of complex task coordination, there will be no better way than with an assistant. And when every brand and every service is available to an assistant to do, it will be a paradigm that's more important than the web and more important than mobile. And at a scale where every connected human and every connected business will be transformed. And we're this close.
Okay. Nell?
Yeah, I think that the missing link to really bring this vision that you just expressed out is probably embodied cognition. For machines to truly understand the world in a similar way that we do, or that a child does, or in fact that, for example, a house pet might, they really need to be able to experience our world in a similar way as we do, in terms of exploring an environment, hearing sounds, understanding people and the relationships between people. And I'm very excited by things like robotic pets. And if you think about it, if you had a miniaturized Tesla that was very small, you know, you could liken that to a robotic pet. So in many ways, the technology already exists, right? And I think if we have these kinds of robotic pets that we are interacting with on a daily basis, they're very quickly going to generate a data set of thousands and thousands of hours of different experiences. And perhaps, you know, all of them sharing their knowledge with each other in different ways. I think we are on the verge of a real leap forward in terms of machine intelligence as soon as we can properly embody machine intelligence within the home.
I think embodiment is an important piece of it, but I think there are still key technological breakthroughs that are missing on the machine learning side to make use of the kind of data that you get from embodiment, or even the kind of data that you get from virtual interaction. I think Adam's comments brought up what to me is a really important point, which is the big successes that we've seen in AI in the last few years emerge when you have very, very, very large data sets. That's true for machine translation, it's true for the image tasks that we talked about, it's true for speech recognition. It's not true for human intelligence. One of the things that characterizes humans is that a child is able to learn from 2 or 3 examples. You don't need 30,000 examples.
Like burning yourself if you touch
or
fire.
you point a child at a dog 3 or 4 times and say, puppy, puppy, and they get it. They don't need to be shown 10,000 examples of dogs in order to learn to recognize a dog. And machines are not currently able to do that. What made AlphaGo so successful is the fact that it had a virtually unlimited amount of training data. It could play against itself as much as it wanted, and that allowed it to really achieve a new level of performance. We need to have a machine learning paradigm that is able to learn from small numbers of examples and also to transfer learnings from one domain to a different domain. And both of these are very nascent in terms of technological ability in machine learning today. And I think that's going to be a major area for improvement, which could then leverage the kind of data that you get from embodied intelligence or anything else. But I think it's a key missing piece.
So I saw very few questions related to when will AI exceed human intelligence, back to the introduction that we made about are we going to remain or be the most intelligent species on this planet. So is that going to happen, or is that even relevant to ask this question? Who wants to answer, Adam?
I'll start. I do think it's absolutely relevant and worthwhile thinking about. Ray Kurzweil wrote The Singularity is Near, and he says there's this law of exponential returns where things get better at an exponential rate, and it's hard for us to imagine this. And he put out a date. Now, he's a famous prognosticator. He's been right on many things in the past. He is on the record saying that 2029 is the year of the singularity, and that means at which point computer intelligence will surpass human intelligence. That's 11 years from now. So, you know, it's worth thinking about. And there are initiatives like, you know, well, people have taken statements like that. Elon Musk and Stephen Hawking have said, literally, Elon Musk said, AI is like summoning the demon, and it doesn't end well, basically.
And he's put up to $1 billion.
And he's started something called OpenAI. I think Nell can tell us more about some of the organizations trying to create safe AI, whatever that means, right? So there's a lot of fear and hype about, is AI going to surpass human intelligence? Well, in certain fields, like playing chess or Go or things, it is, or typing in my calculator.
Yeah.
You know, my calculator is way better at adding or multiplying than I am, right? But I don't have to fear it, right? It's not sentient and it's not going to take over the world. So it's worth thinking about. In my view, as one person, one expert in AI, I don't put it at 11 years. I don't put it in this century. I probably would start at 1,000 years up.
1,000 years.
1,000 years. And the reason I say that, I don't know if that's the exact date, but it's because we need those types of breakthroughs. And for things like how to generalize across tasks, we've made a little progress, but nothing close to what any 2-year-old can do. And especially when, you know, the real fear is that there's sentience that emerges. Now, I'm a founder of a company called Sentient. I can tell you, we do not know how to do sentience, meaning sentience being having an intelligence that can reason and think and feel and scheme to take over against those pesky humans. We don't even know what consciousness is. I haven't seen any work that is leading in that path. So for me, it's a statement to say we need significant breakthroughs.
Right.
And I don't want to diminish, to your point, the accomplishments AI has had in application areas. And I think we should talk more about that later, but it will change lives, probably for good and for bad. But the ability of having a superhuman, real intelligence, conscious, sentient intelligence, we are not scratching the surface, and I think we're so far away. And I think most, I would say, in AI take that view, which is quite different than what the media blows up that, you know, we're all going to die.
Well, we have that question like,
so
how do we stop the creation of a Terminator? Apparently 1,000 years, it's very reassuring. Daphne, do you disagree with this?
I think it's, I agree fundamentally with Adam that there are at least one, and I would argue probably multiple major advances that need to be made before we even get close to this. Each of those is a highly stochastic event that you don't know when someone's going to come up with the next brilliant idea. Once you come up with a brilliant idea, it's usually decades of engineering to really get it to work right once you even have the breakthrough.
And the requisite data set.
I'm sorry, and the requisite data sets. So I think I don't know if it's 1,000 years, but I certainly agree with it. Certainly not in 11. It's not this century. And I also wonder about the utility of planning against an eventuality of a superhuman intelligence whose nature we don't even understand. Because I think it's fairly likely, coming back to the birds and airplanes analogy, that whatever the nature of that intelligence will be, it'll be very different from how we perceive intelligence, because it will probably emerge differently. And so planning how to prevent it from doing certain things that we don't even know if it'll want to do just seems premature to me.
Let's imagine, though, this happens, that you're wrong, and Elon is right, and it actually happens in a few years. We have super intelligence into a robot, and I would like to know, Nell, on your work on how to teach machine ethics. So let's pretend it happens. It's pretty scary. If it does, how do we prevent those
they'll be teaching us ethics if it happens.
Yes, indeed.
How do we prevent those machines from killing us?
Pull out the plug.
There's no more plug.
Well,
Solar.
There is an emerging domain called machine ethics, and it's really at the junction of philosophy, logic, mathematics, and a bit of psychology and social science. And it's really about the art and the engineering of loading values into machines, or helping machines to make decisions which are more in line with our hopes and our expectations and ideally human flourishing. For all AI to advance, every major advance has required a data set of some nature. And I believe that one of the most important tasks today may be creating a data set for machine ethics. And I'm co-founder of a group that's working on that, a group called EthicsNet, trying to create a data set to help teach machines how to act in ways that are kind of like socialized or socialization, ideally making machines a little more kinder. But Adam made a wonderful point about machines teaching us ethics. Over the centuries, we've had various moral advancements in different cultures and civilizations. And we've come up with new ways of modeling ethics, for example, utilitarianism or categorical imperatives and things like that. Now, AlphaGo, to go back to that example, created strategies for playing that game that no human could recognize. And in fact, humans thought were a folly or a mistake or the machine's done something silly until it won. And in a similar way, I think machine intelligence may be able to find methods of moral reasoning that we ourselves may not easily understand. And I think some people in our society may have an epiphany and be like, oh wow, the machine's actually onto something there. And other people may want to hold on to their core beliefs and values. Thank you very much. And I think that could create a bit of a schism in society. And I think that, therefore, for me, the greatest fear is not AI trying to turn the world into paperclips per se, but rather that AI may embarrass ourselves into doing silly things. So throughout history, humanity has suffered various narcissistic injuries when we discovered that the Earth went around the sun and there were many spheres out there in the cosmos. And that led to people questioning the teachings of the church. And that led to things like the Reformation, where entire villages in Germany disappeared because of internecine strife. And later, we had Charles Darwin and the origin of the species and the descent of man, and we discovered that we are descended from apes in a sense. And people said, this is an amazing theory. We mustn't tell anyone. It's too dangerous. And Nietzsche warned that God is dead and we have killed him, and a time of nihilism is coming. And we saw, therefore, in the 20th century, World War I and its sequel, and the totalitarianism of the 20th century as mankind struggled to figure out what new values should be given primacy. And my fear is that machines may be like a magic mirror on the wall that tells us that we are not the most beautiful in the world, that we are in fact ugly or stupid, or that we don't have as much free will as we believe, or that on some level there is darkness in our hearts that will never be expunged. And so we don't know what is coming from machine intelligence, but we do have many examples in history of what happens when people lose their values and something needs to replace them.
I love just one comment that you made, and one thought on this was trying to build data sets to teach the values that we desire machines to have.
Yes.
If last year, Brian Johnson spoke, and he talked about how we might merge with machines, literally at the brain level. He started a company to do brain implants. So there's kind of this picture of maybe it's not an us versus them. Maybe we create an entity, an intelligence with the ethics that we wish we had, and then we meld with it and merge with it. And that's how we improve, evolve ourselves to be better, smarter.
Yes.
So not exactly my perspective, but it's an interesting idea.
But it may be a somewhat more pragmatic aspect of creating data sets that reflect the ethics that we think we ought to have. Comes to some discussions that have been going on about how machine learning models not only reflect but actually amplify biases that exist in data sets that are out there in ways that are potentially quite detrimental. There was a beautiful invited talk about this by Kate Crawford at the Big Machine Learning Conference in December, where she gave some truly horrifying examples of the ways in which machine learning models, in completely inadvertent ways, amplify biases that society has. So a couple of examples, she had a number, is when you search for CEO on Google Images, you get 25 images, of whom 24 are white males, and one is CEO Barbie. So That's kind of a horrible example to give as a role model for our children. She gave another one where if you search for, again on the search engines, for a name that is either represents Hispanic or African American, you get ads that correspond to things that that are very racially charged. Things like, and I'm not advocating this, but things like bail bonds or things like that really, again, represents the worst aspects of racial discrimination. And so how do we create data sets that represent society the way we would like it to be, as opposed to the way it is, so that we prevent this amplification of biases that are inadvertently learned by our machine learning models?
I have two near future or present threats that I'm thinking about. One of them is what recently happened with the campaign, the presidential campaign, and the fact that using AI and learning with data, you can create, basically, you can make Obama or Trump or anyone say anything and make it look really, really real. And the difference now between reality and fiction, as we were talking earlier, is blurring. So was it you, Daphne? Yeah. You were saying that most people won't be able to tell the difference, if not already today, yes, between something created by a machine that is not real and something real, and the threat that there is by learning what we read, the news, and then throwing extremely sophisticated ads that will just change opinion?
No, this is, I think, one of the real risks of artificial intelligence. The Terminator one, I don't think is on the horizon, but this one is very immediate. Nell previously mentioned GANs as a way of creating a synthetic reality, and I think it's one of the ways that people have developed for using machine learning to basically create something that appears real, but is really completely synthetic. Now, while that has tremendous beneficial applications in things like movies, for instance, and entertainment, it also has the negative opportunity of taking something and getting, for instance, a public figure to say something in a video that that person never said in a way that a human or a machine will never be able to distinguish the fake version from the real version. And so then what we're currently seeing in terms of fake news, which is already bad enough, will become almost impossible to prevent. You will never be able to distinguish whether that person actually said what is on video as having been said or not.
So how do we solve that?
I think it's like all technologies, each one of the technologies as we've developed them has huge risks associated with it, and we need as a society to come up with non-technological solutions to try and prevent bad acting. I mean, when we look at nuclear energy, for instance, nuclear energy is a tremendous opportunity, but it also enables dirty bombs. So how do we create societal norms? Because I think technological solutions are not going to be in the same way that technological solutions don't exist for dirty bombs.
We talked about GANs, so which, correct me please, generalized adversary networks.
Generative adversarial networks.
Thank you. So this means that there is an AI creating fake news, right? And in front of that, there is an AI that will look for fake news.
Yes.
And they both fight against each other.
And they get better and better.
Both of them. And at the end, you get indistinguishable from reality or truth.
So it's basically a forger and a discriminator, and they sort of do one potato, two potato, and get better through feedback. And pretty soon you have something that is completely believable and completely
What are we doing in between those two?
And from my perspective, the real problem with this is the creation of super stimuli. In our society, we have developed a lot of super stimuli for things like food, the juiciest hamburger with the most amazing sauces on it, or hardcore pornography, or Netflix, right? You know, and these things affect our culture, and they affect our bodies, and they affect our cultural data set. And it is our cultural data set that makes us human. That is what makes humanitarian human beings, right?
It's funny, you speak about defining human by data sets. So.
Yeah, I mean, I've just...
How about romance and...
No, we are in many ways an emergent property of a cultural data set being fed into this primate.
This is so sad.
It's true, though.
Oh my God, no,
in
it's
many
not.
ways, we are a biological form of AI that happens to be instanced in a primate. And we're created by our culture. That's what makes us. Because if you have a feral child that grows up outside of culture, they don't really act in ways that are human. And yet, if you take a dog and train it and socialize it, it can act in surprisingly human-like ways. And culture is what makes us human.
Great example.
And the thing is that generative adversarial networks and derivatives in the years to come can create super stimuli that no human mind can actually create today.
Give me an example.
Well, I mentioned pornography, for example.
Great example.
These techniques are now creating whatever pornography you want with whatever actor in it.
Pornography on
not
demand,
real.
generated by AI and not real.
Exactly, right? So this is a taster of the kind of super stimuli that we can expect to have in the future. And I think this is going to be very disruptive for our society going forward.
Why?
Because we're going to have so much super stimuli that we're not going to...
Enjoy reality.
Exactly.
You mean, sorry, AI sex created by machines will be better than real?
I think that bona fide cardboard reality is not going to compare with the fantasies that AI can generate on demand for us.
Wow.
One thing that I think is interesting is generating, machines generating what they think humans will want, right? And so the OpenAI project, a lot of people are worried that the fear of AI is that we don't understand them. So we need to create explainable AI so that we can know what's going on and know why does the self-driving car will it drive off or not. But many people have said, if you try to build techniques for the AI to explain it, it won't build true explanations because there's no way a human could comprehend all of the numbers right? So it's going to generate explanations that make the humans happy, so they think they're getting an understanding of what's really going on, right? So there's kind of this other case of AI playing the role where they're trying to anticipate what will get them the good points from the humans, but this level of truth, again, starts to fade when you're like, what is true? What is real? What is real and desirable? And having machines generate all of this with us as the consumers, it's kind of an interesting future.
One more thread, like near-time thread, and then if you agree, we should spend the last 10 minutes only on positive applications.
Yes.
Because
I don't like ourselves.
Yeah, you guys should stop scaring us. So one last one, though. There is 8 million, if I'm correct, but a lot, but 8 million people making their living in the US by driving. So an Uber car, a truck, and if you drive a Tesla, you can see that self-driving is not there, but it's getting fast there. So how do we, like in the next years, 8 million people could lose their jobs? That's a real, right now, threat from AI. Can you react on this? These people will be free and will be able to do something else, also lose their revenue? What will society look like in 5 years, 10?
I don't think any of us know this yet. The optimistic perspective, which I sort of share, although I think it remains to be seen, is that every revolution that's happened, every transformation, the agricultural revolution, the industrial revolution, people were equally worried about all the people who farm. That was 80% of people used to be farmers, and they would all lose their jobs. And sure enough, most of them, in fact, did lose their jobs. There are very few people who actually farm with their hands today, but there's more jobs that were created. In fact, we're at the lowest unemployment point in many, many years today. So I think new jobs will be created. We just don't know what they are yet.
Yes.
And we're not preparing it. Like those drivers are not training themselves.
Well, I think education is going to be a serious issue going forward, because the thing that is going to make humans different from in terms of the jobs that they can accomplish relative to machines are all of those skills that we talked about that machines are currently unable to do and humans, at least in principle, could do better. It's creativity, it's innovation, it's the ability to learn quickly on the job with a very small number of examples to perform a task that you weren't trained to perform. Our educational system is pathetically ill-prepared to teach those skills in school. It's still teaching people for the agricultural age in terms of memorizing facts and memorizing skills that currently computers are either able to do better or will soon be able to do better. So we need to really revamp the educational system so that people are actually prepared for the jobs of tomorrow, which computers are not yet able to perform well.
We're saying that, yet there is a lot of fear that turns not only into good decisions recently.
Yeah, I mean, the World Economic Forum reckons that the kids that are entering kindergarten today, 65% of them will, as adults, work jobs that don't exist today. And you know, we need to move away from reading, writing, and arithmetic and get to complex problem solving, collaboration, and empathy, and critical thinking. And I mean, I think there are some interesting options that maybe people aren't considering. People talk about universal basic income and, you know, the idea of basically taxing a bunch of people and spreading the wealth. But I think there are opportunities within the free market with basically robot-controlled businesses. If you think about it, things like distributed autonomous organizations have some automation at the center and then humans at the edges. And there are companies today like Newman's Own, the company that makes like mayo and Thousand Island dressing, and all of the profits go to charity. But what if you were able to bootstrap a machine-controlled business and the machine was able to handle much of the business activities and hire human beings to do the bits that it's not good at? Therefore, you could create all kinds of robot businesses that operate within the free market, but generate profits and dividends that go directly to human beings. And I think these kinds of strange structures are going to be emerging over the next 5 to 10 years. And some people in this room, by around 2025, will be employed essentially by a machine.
Okay. Yeah. That's a very interesting.
It's time to move to the optimistic note.
Yeah, let's go to the. Okay, how about education, Daphne?
Well, let me talk more broadly.
And you created Coursera, so you know. Yeah, talk more broadly, but let's focus on the positives, please.
So, so I think one of the focus areas that this panel was supposed to talk about was some of the exciting areas where AI is not currently making an impact, but I think is on the verge of making an impact. And there's some of those areas that I'm particularly excited about, and I know we each have some of our own. I think we talked earlier about the importance of data as a driver for machine learning and artificial intelligence. And there's significant application areas where up until the last year or two, it's not been possible to create the kind of large data sets that machines are able to learn from. Some of those areas are, for instance, in the area of agriculture or energy, where the Internet of Things, which are now instrumenting every single aspect of our life. Michael Dell was on talking earlier about the fact that there's 40 billion microprocessors that were sold last year for 7 billion people. So these are measuring every aspect of existence and can allow us to do things like intelligent agriculture, intelligent energy that are not yet feasible today. An area that I'm personally excited about and have been working in for more years than I care to admit is the area of biology and medicine. And that's similarly an area where 5 years ago, a large data set was a couple of hundred samples. And now, for instance, in biology, new technologies like next-gen sequencing and microfluidics and robotics and high-speed microscopy and many, many others are now able to get millions of data samples within a matter of weeks. Now, we don't yet have the right machine learning techniques to leverage all those data sets in these new domains. It requires thinking about domains that are different from images and text and speech. But I think that's the next stage to come now that the data sets are now becoming available.
So for health, for example,
health is a terrific example. Electronic health records, resources like the UK Biobank, which have very deep measurements of 500,000 individuals, genetics as well as everything about them, are now enabling us to measure things about humans that can allow us to make a very big difference in how we diagnose disease, how we treat disease, how we develop drugs for diseases where we don't have effective medications. And I think that's a transformation whose time is now, and it's a very exciting direction for the field to take that is beyond the kinds of applications that we've been able to effectively.
Adam?
I think, you know, going to where the data is super interesting and important. So some projects I'm excited about that I've seen in the literature, one in agriculture. So my company Sentient is working with MIT Open Ag project where they built a food computer. It's like a container where you can grow food, but everything is instrumented and controllable. So you can say how much light, how much humidity, how much salinity, et cetera. And we've been growing food for 10,000 years. The question is, what's the optimal way to do it? And through machine learning and this iterative loop, the system has learned new properties about growing food that we didn't know, such as it was currently thought that, you know, we live on a planet that goes around the sun, it gets light and dark, and that we spin. It was thought that plants need, like humans, a rest. But they found that continuous light during certain periods will actually improve flavor on plants. Nobody knew that. Things like this about how to maximize yield and taste, we can get better. Another in the health area, I read a paper that today imaging for cancer, we're achieving superhuman performance with image recognition compared to humans. And there was a paper that said for breast cancer, there are many we're not sure, and there are many operations that are unnecessary. And the findings said something like 60% of surgeries could be reduced, unnecessary surgeries, by the current level of superhuman performance using image recognition for detecting breast cancer. So there are so many interesting ways that are coming that will improve our lives. You know, AI is a tool for really optimizing our existence, but a lot of it comes down to data and technique.
Yes, and
Nell?
I think we're going to see a lot of optimizations in our social structure as well, or I hope so anyway. We had the first revolution, which was about motive power, right? Steam, internal combustion engine, electric motors, and these things have replaced our brawn. And then we had the information revolution, which replaced our ability to remember things and to share ideas with others.
To think.
Yes, and I think we're going to see an augmentation of our hearts and souls, I believe. In the confluence of...
There is room to grow.
There is, a lot. In the confluence of AI, blockchain, and machine ethics. And I think that blockchain and its derivatives are a very, very important trust-building technique in our future society. And I think...
Why?
Because it's a triple entry ledger. So basically there is, it's a way of trusting what people say and if a thing actually happened, right? Or whether something is counterfeited or bogus. Now, when you put trust in AI with machine ethics, so you know that machines are acting in your best, looking for the best outcomes and the most flourishing possibilities, then we can create social structures which are more about finding non-zero-sum outcomes, basically looking for opportunities for symbiosis in society, looking for ways for people to play together more nicely with less winners and losers. And I think ultimately there is an amazing opportunity in creating new social technologies based on the confluence of AI, machine ethics, and blockchain altogether.
Awesome. Well, that concludes our panel. Can you just raise your hand if you are more scared than at the beginning of the session with AI? Yes? No. So, well, the minority. So raise your hand if you are enthusiastic about the future and you think it's a better opportunity than a threat. That's very reassuring. I think you guys did a great job. I would like to thank you for attending this session and thank you for a fascinating conversation. Thank you very much. Have a great South by Southwest.